Caulking is both the processes and material to seal joints or seams in various structures and some types of piping. The oldest form of caulking is used to make the seams in wooden boats or ships watertight, by driving fibrous materials into the wedge-shaped seams between boards. A related process was formerly employed to join sections of cast iron sewerage pipe. Caulking is also the term to describe the process used to make riveted iron or steel ships and boilers watertight or steam-tight. The same term also refers to the application of flexible sealing compounds to close up gaps in buildings and other structures against water, air, dust, insects, or as a component in fire stopping. In the tunneling industry, caulking refers to the sealing of joints in segmental precast concrete tunnels, commonly by using concrete. Historical uses: wooden shipbuilding. Traditional caulking on wooden vessels uses fibers of cotton and oakum. These fibers are driven into the wedge-shaped seam between planks, with a caulking mallet and a broad chisel-like tool called a caulking iron. The caulking is then covered over with a putty, in the case of hull seams, or else in deck seams with melted pine pitch. In a process referred to as paying, or calefaction, modern marine sealants are frequently used now in place of the pitch, or even to supplant the oakum and cotton itself. Iron or steel shipbuilding. In riveted steel or iron ship construction, caulking was a process of rendering seams watertight by driving a thick, blunt chisel-like tool into the plating adjacent to the seam. This had the effect of displacing the metal into a close fit with the adjoining piece. Originally done by hand much like wooden vessel caulking, pneumatic tools were later employed. With the advent of electric arc welding for ship construction, steel ship caulking fell into disuse. Boiler-making caulking of iron and steel, of the same type described above for ships' hulls, was also used by boilermakers in the era of riveted boilers to make the joints watertight and steam-tight. Modern use in construction. Caulk can refer either to the caulking substance or to the process of applying it. Caulking as a term has spread to the building trade, meaning the activity of closing up joints and gaps in buildings. The function of caulking is to provide thermal insulation, control water penetration and noise mitigation. This is mostly done with ready-mixed construction chemicals sold as caulk such as silicone, polyurethane, polysulfide, silyl-terminated polyether or polyurethane and acrylic sealant. Unlike construction caulk, which is applied where no building movement is expected, a sealant is made of elastomeric materials that typically allow movement of 25% to 50% of the width of the joint. One-component sealants are commonly sold in cartridges which are loaded into a pistol-like caulking gun or barrel gun for application. During the tool working time, which varies by chemistry, the bead can be pressed into the joint so that it can bond with the materials on both sides, and also be smoothed. The time it takes for a chemical sealant to become a rubber is known as the curing time and varies by temperature and humidity. Silicone sealants form a durable, watertight seal, but are not typically paintable. Some silicone sealants are made to be paintable with certain types of paint such as water or oil-based paints. Other sealants are paintable. Backer rod, also called backer material or backup rod, is a flexible foam product used behind caulking to increase elasticity, reduce consumption, force the caulking into contact with the sides of the joint creating a better bond, determine the thickness of the caulking, and define the cross-section hourglass shape of the caulk. The backer rod also acts as a bond breaker to keep the caulking from sticking to the bottom of the opening, called a three-sided bond, with the caulking only adhering to the size of the opening in an hourglass shape. It can flex more easily and is less likely to tear. Backer rods are also be used to reduce consumption of the caulking by filling part of the joints. Backer rod is often round and rope-like in shape, but many special types and shaped such as square, rectangular and D-shapes are available. High-temperature backer rods are available. It is available in different diameters and firmness, and in polyethylene and polyurethane materials. Backer rod also comes in open cell and closed cell types of foam. Open cell foam is porous, so it will let gases through which could otherwise cause blistering of the sealant. Also, open cell backer rod allows air to get to the backside of the sealant, which accelerates curing when used with air-cured sealants such as silicone. Open cell rod is more compressible than closed cell foam and should be 25% larger diameter than the joint. Closed cell foam does not absorb water and is impermeable. Closed cell rods are less compressible and should not be compressed more than 25%. Closed cell rod will also lose firmness and outgas if damaged during installation or overcompressed or at sharp bends. The gases cannot pass through this backer rod and can deform, weaken, and even cause holes in the sealant as it escapes. Outgassing is the reason open cell backer rod was developed. The hourglass shape and thickness of the sealant are important. The hourglass shape provides the appropriate adhesive strength to the object at the sides of the joint in relation to the cohesive strength of the sealant itself. The depth of the sealant affects these strengths. Too much or too little sealant can result in failure. The standard recommendation is to place the backer rod 1/2 the width of the joint below the surface, but not more than 5 inches. Ordinary open cell foam is used up to 500 degrees Fahrenheit and ordinary closed cell can withstand temperatures up to 160 degrees Fahrenheit. Some backer rod may be applied with special tools to make it easier to set the backer rod at the correct and consistent depth. If a joint is too shallow to receive a backer rod, bond breaker tapes are available to keep the sealant from adhering to the back of the joint. Energy efficiency. According to the Consumer Federation of America, sealing unwanted leaks around homes is an excellent way to cut home energy costs and decrease the household carbon footprint. Also, sealing cracks and crevices around homes puts less strain on home appliances and can save time, money and hassle by preventing major repairs. Additionally, increasing the lifetime of homes and appliances also puts less waste and pollution into landfills. Preventing infestation. Sealing cracks and crevices prevents ingress by rodents.